Yesterday we are discussing about Hive. What is Hive? What is the importance of Hive? Why you using Hive? And we had seen some historical aspect of Hive. Now, and also we have given about the Hive architectures. What is how Hive architectures are working. So today we will going to discuss about details about the Hive architectures, how the Hive architectures inside Hive architectures, how it's going to execute the job, how it's going to execute the query. Okay, that's we're going to discuss in detail in today's sessions. So here, this is the job executions inside the Hive. Okay, in Hive, how the job is going to be executed. Suppose if you are SQL developers, right? Because I told earlier that this Hive is nothing but it is the interface through which we can write SQL query, and that SQL query will be converted into the MapReduce programs or MapReduce jobs. Okay, so it is a interface. Okay, it is a kind of interface, or we can say it is also Hive is a translator through which we can translate SQL query into the MapReduce programs. Okay, so that things we discussed in the last classes. Coming to the job execution inside the Hive. So before going to see this detailed architectures, let me explain you some basic concepts. That suppose we have Hive client. Okay, Hive client. This is Hive client. Okay, then we have Hive services. Hive service. Hive service. Then we have data processing. Data processing. And resource management. And resource management. Resource management. Resource management. Then we have distributed storage. Distributed storage. Right. Now, what is Hive client? See, if you want to interact to the Hive server, or if you want to avail the services of the Hive, you should have the Hive client, right? It means you are going to interact to the Hive service through the command line interface, which is called as CLI. CLI means what? Command line interface. So if I am going to write just like Hive, and if you enter it, you are entering into the cell of the Hive. So through this, we are going to interact and we are going to avail the Hive services. It means you can create a table, we can load data into table, we can do all the operation into the Hive services. For that, you are going to use what? You are going to use a Hive client. Okay. Now, suppose if you have a server, say Hive server, right? If you have a Hive server, then to interact to the Hive server also, we need to have Hive client, and for that you are using called as beeline. What you are using is, we are using a beeline. Beeline is nothing but it is a client applications. It is client applications. So if you want to communicate to Hive server, we can install B client, and you can connect through JDBC and ODBC. You can connect and you can avail the services of the Hive servers. Okay. Now here the next step is what? Data processing. It means we are giving the queries, and that queries will going to be fired, right? And we are going to perform the MapReduce task, and we are going to get the results only. Okay. Now we are going to see here how the things are happening. Now suppose I am Hive client. Okay, Hive client. Now I am submitting the query. I am writing some query. If you are writing some query, any SQL query, or which is called as HQL query, because the Hive is based on HQL. It means the language which is used by the Hive is called as HiveQL, or it is also called as HQL. Okay, so you are the Hive client, you are submitting the query. This query goes to where? This query goes to the driver, because the drivers will going to accept the query. Okay, who will going to accept the query here? The driver is the one who is going to accept the query. So whatever the query is submitted by the Hive client, that must be accepted by the driver. The driver is going to accept this query. Now this driver, what he will do, this driver will give this query, or which is also called as plan, can call as plan, to compiler, to the compiler, okay, to compile the query or to parse the query, to check the query whether syntactically it is correct or not correct. Okay, so here you are giving, client is giving query, it must be accepted by the driver. The drivers forward this query to the compilers for parsing, for checking the queries syntactically correct or not correct. Now here, how the compiler is going to parse the query? Because the compiler should get some data, okay? The compiler should get some informations, right? In order to parse this query, okay? So here, the compilers need what? The compilers need a data which is called as metadata, which is called as what data? Metadata, okay, which is called as metadata. Because in order to process this query, the compiler must get metadata. Now your question is, what is metadata first? What is metadata and how we can define the metadata? Generally we are telling data about data is called as what? Metadata. Or you are calling the information about other data is also called as what? The metadata. Okay, that's logically we are speaking in that way. Now here, metadata means you are talking with respect of Hive. Now let me give an example for you. Suppose we have a document, right? We have a document. In document we have many informations, we have many things inside the document. If I ask you, what is the metadata of this document? Then what is your answer? The metadata of this document may be the author. The author of the document is one kind of information about this document. You can call as date created, at which date the document is created. That is also one data for this document. In which date document is modified. In which date document is modified. That is also one data. And what is the size of the document? This is also called as one data. So we are giving some information about this document. That is going to call as what? Metadata. So here I can say author, date, and size of the document, in which date this document has been modified. This is going to call as what? It is going to call as metadata, right? Now why this metadata is important? Because this metadata is going to refer the data, is going to find the location of your data, where this data is located, right? Now see, data is where? Data is in our SDFS. In SDFS we have a data, right? In SDFS we have a data, right? So whenever you're going to give some queries, right, we have to find out where this data is available. Then only this query is going to be work, right? You're going to get the result after firing this query. So we need some information about the table, where table is created, definition of the table, schema of the table. Okay, this is going to call as metadata. Okay, if I say definition of table, schema of the tables, right? So these are the metadata, right? So this metadata is very important to execute your queries. Now our next question is that where you are going to store this metadata, right? We need some place where we can store this metadata. So where you want to store this metadata, we have to store this metadata, which is called as metastore. What is going to call as metastore? Metastore is the place where we can store this metadata. Okay, where you are going to store this metadata? The metadata can be stored only in the metastore. Metastore is a place where we can place the metadata. So metadata is stored here. Okay. Now generally, if you install Hive, the default metastore, there is a default metastore, or in Hive we have default metastore, which is called as embedded metastore. Embedded metastore. Embedded metastore is a type of metastore which is come as a default when you install a Hive. So whenever you install a Hive, we are going to get what? We are going to have one categories of metastore which is called as embedded metastore. Okay. So by default, this metastores will be available, which is called as embedded metastore. In this embedded metastores, we have one database which is called as Derby database. What is going to call as Derby database, which is called as Derby database. This Derby database is going to store your metadata. Is going to store your metadata, which is called as Derby database. So Derby database is what is come under embedded metastore. So in embedded metastore, we can find a Derby database which can store the metadata. But we have a problem in Derby database. We are facing one problem that this Derby database will support only single instance. It means it supports only single connections. You cannot have a multiple connections in case of Derby database. It is not possible to create a multiple connections. We can have a single connections. So if we have a single connection, means what? We are not going to give access to of many users, right? So this is a drawback of Derby database. So in order to overcome this drawback, we can configure it by yourself. You can change this Derby database as a RDBMS database. You can configure it. You can configure it as what? As RDBMS database. Instead of using Derby database, you can use MySQL. You can use and you can configure it so that the problems can be easily resolved. Okay. So this is what about the metadata. I hope you understand about the metadata, because the metadata is the one who is going to give projection where the data is being stored, right? And it's going, so here what happens, these compilers want to check everything. So what he will do, the compilers will send request to whom? To metastore. What happens, the compiler is going to change what? It is going to send the request to whom? To the metastore. So this compilers, what will do, the compilers will send request to get metadata, from where? From the metastore, and metastore will be any database. As I said, any database you can have, right? You can have any database. So what compilers will do, the compilers will just ask metastore, I need metadata. Okay, so what metastores will do, the metastores will take the request of the compilers and he will give response. What response will give, the metastores will provide the metadata for the compiler, So the compilers will start the parsing process. It will check the query, the plan, whether the plan is syntactically correct or not. Everything parsing will be take place, right? Now, so what happens here, the compilers will get the metadata from the metastores, and here the compilers will do the parsing process. And then what happens, the compilers will send again the same plan to whom? Same plan means the same queries to whom? To the driver, right? You know that the first driver has given this plan or this query to compilers, then compilers send request to metastore to get the metadata and start executing the plan. After executing, what happens, it has resent this plan to the drivers. For what? For execution of this query. So for execution of this query, we need to have execution engine. What? You need to have the execution engine, right? So you see how these things are working here. So metastores has given data, compiler is going to compile the query, parsing has been done, resend to drivers, the drivers will send this plan to execution engines. Now here the execution process is going to be started. Execution process means what? Your queries will be going to convert into the MapReduce, and here within the Hadoop, the MapReduce program is going to be executed, and you're going to get the results, and result will send back to the client once again. So these are the basic steps we are going to follow to execute the query within the Hive. Inside the Hive, how the query is going to be executed. Okay. Now, in Hadoop we have SDFS is there, which is called as distributed storage, because here the data will be residing. So here you are going to get projections, projection through the metadata, right? So here we have SDFS. In SDFS we have data are residing. Now here, how is going to MapReduce programs is going to work? We have a job tracker, right? Then we have what? We have a task tracker, task trackers. Job tracker is going to call as master, who can assign tasks to the task tracker, and task trackers will be within the data nodes, who will going to execute the queries, and result will send back to the clients. In this way, this query is going to be executed. So hopefully you understand some basic idea about this the Hive executions, how the executions will be take place, and the executions engines will take care about your executions of your job. Okay, how the job will going to be executed. And execution engines always try to get the information of metadata from where? From the meta stores to complete this execution process. So this way is going to happen. So now we can see this job execution inside Hive. As I told earlier here, the same thing, it can be explained here, that we have interface, that is your client. The client is going to send the queries to the driver. The driver is here, right? We have call it the driver. Now this driver, what he will do? He will give this plan or this query to the compilers. Now the compilers need metadata. It needs metadata. So what he will do? He will take this metadata from the meta store. Meta stores may be any relational database. Okay, as I told earlier, it may be any relational database. So in meta stores we can find the metadata, and this metadata will be sent to the compilers to complete the compilation process. Okay, to perform the parsing. Once parsing is done, again this plan has sent to the driver for execution. So for executions we have what? We have an execution engines available. Okay, this execution engines, what you will do? You'll try to interact to the Hadoop, because your queries should be fired, right? You should fire the queries. So this is your Hadoop ecosystems we have. This is called as Hadoop clusters. This is called as what? Hadoop clusters. In Hadoop clusters we have job trackers and task trackers. So this job trackers and task trackers is coming to perform MapReduce task. So job tracker is going to call as master, and task tracker is going to call as slave. Okay, so job trackers will assign the task to the task tracker, and task trackers will always reside on the data nodes to perform the MapReduce task. Okay, so now from where this MapReduce task, this task trackers will get data? They will get data from the data nodes, because this task trackers always reside on the data nodes. Okay, so this task trackers will interact to data nodes and is try to complete the executions. Okay, here we have a name node. See, in SDFS also we have two types of node. One is called as name node, second is going to call as data node. Name node is called as what? The master. Okay, and data node is going to call as what? The slave. Here the master can communicate each other, and slave can to communicate each other. It means that the name node can communicate to job tracker, because job tracker is also master and name node also master. Similarly, data nodes we also communicate to the task tracker, because data node is also slave and task tracker also the slaves. So they will have a formal communications among themselves. Okay, now this name node will maintain the metadata. Okay, so what is maintained about the metadata about your file. So you have metadata, right, in the name node. So here in this Hadoop clusters, we are going to fire the MapReduce programs and to get the results, and this result again send back to the users, and users will going to get the results. Okay, in this way this job executions will happen inside the Hive. Okay, so this part is called as Hive part, right? This part is totally Hive part. In Hive parts you can perform this much of process, and then you have to pass to the Hadoop. In Hadoop you can perform the MapReduce operations, so that your queries will be executed and you get the results from the Hadoop clusters. Okay, so this is what about the job execution inside the Hadoop. Now the same things I had just given steps here. Just see first execute query. Okay, so the Hive interface such as command line, as I told that we have an interface such as called as command line interface you can have, or you can have you can interact to the Hive services, and you have a driver may be any database driver such as JDBC and ODBC. So this you have to execute the queries, right? Then you have get the plan. It means your query should be given to the driver. Drivers takes the help of the query. Compilers that parse the query to check the syntax and query plan or the requirements of the query. So what this driver has did, driver has given their plan, that is the query, to the drivers, right? So we have get metadata. So if compilers want to compile it, the compilers need metadata from the metastore. So the compilers send metadata request to metastore, because metastore will be any database, right? Then we have send metadata. Metastore send metadata as a response to the compiler. So who will going to send the metadata? The metastores will going to send metadata to the compilers to complete the parsing process. Then send plan. The compiler check the requirement and resend the plan to the driver. So after compiling, the same plans will send to the drivers, and here the parsing and compilation of the query is complete. So here what happens? The parsing is already completed by the compilers. Next, execute the plan. So how to execute the plans? We have to pass this everything to the execution engine. The execution engine will take care about to execute the plans, to execute the queries. Then execute job. Job means what? See, whenever you're going for execution of any plan, that becomes a job. So here the execution of jobs will take place. It means you're going to perform MapReduce jobs, MapReduce operations to get the out. And metadata operations will take place, because execution engines always interact metastore to get the metadata. And finally, you're going to get what? Result from the Hadoop clusters, right? The Hadoop clusters will going to give you results to your queries. Okay, so this much steps you need to follow, right, in order to get the results from the Hadoop clusters, right? We have to, this much steps you need to follow it, right? We have to first install your Hive, right? Then we have to interact to the driver, submit your queries to the driver. The drivers will send to the compilers. The compiler is going to compile based on the metadata. The compilers will try to fetch metadata from the metastores, and after compilation it passed to the driver again. Drivers will give it to the execution engines. The execution engine, the execution of the queries will take place, and finally you're going to get the results. Now this one I want to show you in somewhat practical aspect or somewhat real-time scenarios. Okay. Now suppose you just imagine that you are data analyst. Data analyst you are. It means you are going to analyze some data. So what you'll do is that you know only SQL queries. You know only SQL, how to work in SQL. You know only HQL. You know only HiveQL. You are very good in SQL. So you are data analyst and you want to interact to the Hadoop. So because you don't know Java, you don't know how to run Java program, how to create jar file. So you are away from that because you are using the Hive interface. So you want to type a queries. So here what you're doing is that you are giving queries to whom? Suppose this is query you are giving. Select count from cells. Okay, this is a query you are going to give. What queries you are going to give? You are going to give a queries called as select count to cell. So you are going to count the total queries. So you are giving queries to your this Hive. The Hives you are going to give it to the Hadoop clusters, where the MapReduce jobs will be take place. Here the MapReduce docs will be take place. So once you're going to give query, then only the query is going to convert it into the MapReduce programs. Okay. So here once you providing the queries, these queries go to the Hive, and from Hive it comes to the MapReduce programs, and from there you're going to get the results. The results will get back to the data analyst. Will be executed by the SQL data analyst, and this is the data analyst. He knows only SQL, so therefore what he will do, he will try to fire the queries, and that queries were converted into the MapReduce programs, and he try to fetch information from the HDFS and get result back to the analysis. So this is what about the Hive architecture. Coming to next topic, we have called as Hive data types, right? See, in Hive, we are going to create a table, right? First thing, we are going to load data into the table. Second thing, we are going to do some operations, right? We are going to do some operations, and finally you are going to get result from the tables. So this Hive is only projections. All of your data is stored only in Hadoop, that is in SDFS. Okay, and through query only we are going to get results from the Hadoop only. Okay, so if you want to create a table, just like SQL, we have to use data types. Just like in SQL, in Oracles, in MySQL, they are using different types of data types. Similarly, we have different types of data types is available inside the Hive. We have numeric data types, that is called as teeny int, which can have only one byte. Then we have a small int, it can store 2 byte side integers. Then we have integers data types, we have only 4 bytes. Then we have big int, which can store only 8 byte of informations. We have float, who can have only 4 byte single precision floating point. Okay, you can store all decimal numbers using the floats. Then we have the double 8 byte double precision floating point numbers. So you can also store it here with the floating point number also. So these type of data types is called as what? Numeric data types. Okay, so based on the byte, for 1 byte we have teeny int, for 2 byte we have a small int, for 4 byte we have an integer, for 8 byte we have a big int, and for 4 we have a float, and for double we have a 8. So this is one numeric data types. Then we have the string data types we have, right? For the strings you can have var characters and you can have the characters. So these are very famous for the string types. So you basically are going to use var characters or the characters. For var characters is available with Hive 0.12.0, and you can find these characters with these versions Hive 0.13.0. Now this is a miscellaneous type. Okay, only available strings with Hive. So this is miscellaneous types. We have Boolean and we have binary also. This is called as the complex data type. What is going to call as a complex data type? We have a stacked, just like a C structures, right? Now, because in a stacks, in a columns, we have multiple values. You have multiple values in the columns, and you can access using the dot operators. So just like a stacks, we have this is John is the first name and Doe is the suppose last name. Similarly, we have the map is also complex data types. You can have collection of the key. So in map, you just map is the data types, and you can just keep as a key value pairs, because the map use key value pair, right? I think you know about what is the meaning of key value pair. The mappers will get input in the terms of key value pairs. It produces output also in the terms of key value pairs, right? So here the mappers accept what as input as a key value pairs. And how we can generate key value pairs? We have a call as record reader. The record readers is the one who can take as input and convert into the key value pairs, and key value pairs are going to assign to the mappers. Okay, so similarly here this mapper is nothing but it is going to act as a collection of the key value pairs here. Okay, for example, I can say here the first John. See, I can say first name as a key, or John is called as value. I can call as last as a key, or Doe is going to call as a value. So it's going to have the key value pairs, and you can field access using these notations. Okay, now this is the map is basically used to have a collection of key value pairs. So if you want to store data as a key value pairs, you can use what? You can use data types called as map. We have array. It's array because it's going to access with the same data types. If you have same data types, you can use the array and it follow the indexing, right? Suppose array is given, we have a John, for you have 0 indexing, for Doe you have a 1 indexing. So just like a array, we can use as a complex data types. Also we have one data types called as union. Okay, union is also one data types which can be used in hives, because in columns, if you are going to store different types of data types in one columns, that time you can use a union data types also. So these are called as Hive data types. Now next you are going to see the Hive file format. Okay, what is file format? It is a way in which information is stored and encoded in a computer file. So in computers, how we are going to store the information? Okay, now we know that some people can store information as a text file. Okay, as text file you can store the informations. You can store information as image file. You can store the information as image file. So we have different types of formats are there through which we can say how we are going to store information inside the computers. It is a way of representation, how the informations can be encoded within the computers. That is going to call as a file formats. Okay, the file formats is very important in SDFS because here the file formats are designed to allow to speed up the read and write process. So if you want to read and write process, right? If you want to read and write process, right? If you want to perform read and write operations, we need to have the file formats, and also we have provide compression support. Suppose if you want to compress the file, then you should have also the compression support. So here these are the we are using different types of file formats because file formats is very important for the Hadoop also, right? So we are going to see which file formats you are going to have in Hive file formats. You are going to see one by one. Here types of Hive file formats. One is called as text file. So this text file is default one, right? The default file format of Hive is what? Text file. So if you are not going to write, if you are not going to specify any kind of format, by default it going to take as a text file formats. Next we have sequential file. We have sequential files are the files that store binary key value pairs. What is meaning of sequential file? Okay, now let me give some example about sequential file. See, this sequential file is basically used in Hadoop. What are you going to use? You are going to use in Hadoop sequential file. It is also called as a flat file. Why are you going to use sequential file? Suppose you just take one example. Suppose if you have a small files are there. We have many small files are there. Suppose one file is this one, which is a small file. We have a file 2. Okay, we have also it is a small file. So like this, we have many small files are there. See, if we have many small files are there in Hadoop, it create a severe problem. Why? Because if you have so many files are there in the Hadoop, a small file, say one file size is only 100 KB. Suppose 100 KB. File size is how much KB? 100 KB. This 100 KB is very less than the size of the block in SDFS. Okay, it's very less than what? The size of the block in SDFS. Because in SDFS, if you take Hadoop 1.0, if you take Hadoop 1.0, the default size of block size is how much? 64 MB. How much MB? The default size of the block in Hadoop 1.0, 64 MB. But the same thing if you take Hadoop 2.0, in Hadoop 2.0, you can find 128 MB, 128 MB. Just imagine. This is the size of one block I am talking. The size of each block in Hadoop, if you are taking Hadoop 1.0, you may get 64 MB. If you are taking Hadoop 2.0, you can get 128 MB. And just imagine if your file size is less than the size of the block, then it is also a serious problem, right? Now, like this, if you have the small file means what? The file which size is less than the block size of SDFS, that is called what file? A small file. So if you have a small file, then it is very burden to perform map task. Because for every file you need to perform the map task, so map task will be overloaded. Because of that, what happens? The execution time will become slow. The execution time also becomes slow. This is one of the serious problem. So once you have many files, it means you are loading the mappers. The map tasks become overloaded. For every file you have to run map task. For every file you have to run map task. So map tasks become overloaded. And what are the execution time? Execution times become very less. So you will get the results very slowly. That is one problem. Second thing, for every file we have to maintain the metadata inside the name node. Metadata, right? Suppose we have a metadata. For this file we have metadata. For this file we have the metadata. And for this file you have the metadata. For all this metadata, who is going to maintain? Name node is going to have information about the metadata, because name node is going to have the metadata. Metadata who is going to have? Name node. So name node is keeping information about this all metadata. So it means you are loading the name node also. So these much problems are you're going to have if a small file. So how to solve this problem? To solve this problem, what you're doing is that we are going to combine all this file and making as a sequential file. What you're making as a sequential file. Okay, all files should be combined. Okay, say file 1, file 2, file 3, file 4, 5, all, and they are going to make what file? Sequential file. Okay, so this a long file going to get what file? It's a sequential file. So sequential file also use what? Used to combine all the small file. Suppose if you have 1000 files, how many files are there? Suppose if you have 1000 files and each file is having what? 100 KB. How much KB? 100 KB. If it's so, then 1 GB is enough. 1 GB is enough to have sequential files. How much capacity? It may have 1 GB. 1 GB is enough to get all these files in a sequential file. Now here, this sequential file is going to place this information in the forms of key value pairs. What? In the forms of key value pair. Key value pair. Okay. It means you are going to store the informations in the forms of key value pair only. Suppose if I take one file if I am taking, so the key must be the name of the file. I can call as the name of the file is going to call as what? The key, and the content of the file I am going to call as what? The value. Okay, so if I am saying the name of the file, I can call as what? I can call as the key, and the content of the file I am going to call as the values. Okay, in this way what happens? The sequential file will store the information. Now this sequential file also store the output of the mapper. If you want to store the output of the mapper, you can use what? You can use a sequential file. And this sequential files is going to represent the file in the forms of key value pair only. Okay. So this is what about the sequential file. So the sequential files are flat files that store binary key value pairs. Now we have another files which is called as RC file, which is called as record columnar file. Okay. This file is basically used to perform analytical of data. Suppose if a huge data sets are there, and if you want to perform analyzing of this data, we can use a record columnar file. Okay, because the data analysis need huge data sets, and they will keep all this data set in the forms of columns. Okay, so that they can access information very fastly, and they can do analyzing of that data. So that format is going to what format? It is called as RC file, or it is called as record columnar files. The next is called as ORC file, which is called as optimized columnar file. Okay, this kind of file is basically used to optimize the data, right? If you have a huge amount of data and if you want to optimize it, okay, if you want to optimize it, we have to use ORC file to increase the performance of your system. Suppose if you want to improve the performance, we have to use the ORC file so that all data must be optimized without changing the context of the data. That is going to call as what? ORC file. So here, which is the default file in Hive format? Text file is default file in Hive format. If you are not going to specify the file format in the Hive take as a default text file formats. So by text file formats, it will remain as a default in the case of Hive file formats. But if you want to store your data in the terms of sequential file, then you need to specify store as sequential file. Store this data as sequential file. You need to mention. Okay. So for sequential file, for RC file, you need to specify that your data must be stored in the form of RC file or in the forms of ORC file. It must be specified. But if you are not going to specify any kind of formats, definitely you are going to get what kind of format? Text file formats. Now this is the text file formats example I am giving here. We are creating a table, okay, just like it's SQL queries. We are going to create a table, okay, table name is Olympic, and in this we are going to specify different fields, different attributes. We have athlete, string is the data types. We have another field age, string is a data, string int is a data types. We have a country string is what? Data types. We have year, string data types. We have a closing, string is what? String is the data types. So this is going to call as what? These are going to call as the data types. Okay. Closing, string, these are going to call as what? Data types. Okay. So we are going to create a table for Olympic. Okay. And just like we are going to, and here, how we are going to create a table? We have to write a row format delimited. What is a row format delimited? Suppose if I am writing the record, first record is over, then automatically you have to go to the second row. Go to the second row, and then go to the third row. Like this, what happens? We have to use row format delimited. Okay, and here the field is terminated by tab. It means if I'm writing first field, suppose if I'm writing name of athlete is Mr. Rahul, suppose I'm writing Rahul, then the field must be separated by tab. You have to give some space. Then you have to write age may be 32, country may be India, okay, year may be say 1999, sports may be say cricket. So what I'm doing here, I'm giving some tab between each field. Okay, for that we have to mention field terminated by tab storage text file. So here you are going to specify this text file. Here no need of also specifying text file. If you are not going to specify text file, what happens is going to store what in the forms of text file only. So here what we are doing is that we are just creating a simple table. Create table. This is Olympic is a table name, and within bracket you are going to specify the field with the given data types, and you're writing row format delimited, so it's going to be in the forms of row only, and every fields are giving some instruction that the fields will be terminated by some tab. So everything you're going to have some tab space between each and every field. We can also write by semicolon. It means what happens? The fields are terminated by the semicolons. If you write only colon, it means what? The fields will be terminated by the colon only. Okay, it's going to be terminated by the colons only. So it means that we are going to write this syntax to create a table. First write create table, table name, specify the field and data types. Then you have to write row format delimited, fields terminated by tab, and store as a text file. Okay, if you do like this, what happens? Your table will be created. What table? Olympic table will be created. And describe Olympic, you have to find this athlete. Athlete is your field. What is data type? Data type is string. Age is a field. What is data type? Data type is integer. A country is what field? What is data type? Data type is string. Year is a field. What is data type? Data type is string. Similarly, closing is what? Is a field. What is data type? Data type is string. Export is also attribute. What is data type is what? The string. The gold, right, is a field. What is data type is integer. Silver is a field. What is data type is integer. Bronze is field. What is data type is integer. Like this, what happens? The tables will be created. So what happens here? Tables is created. Now this is the schema of your table, right? The structure of table has been already completed. You are giving a schema of the table, right? So in these tables we have following fields are there. We have already described the schema of the table. Now here we have to load the data to this table, right? In Hive, whenever you want to load some data to the table, we have to use some of the command. How to load data inside this table? Because in these tables you are going to load data about athlete. You are going to load data about the age of this athlete. You are going to load data about the country, from which country he belongs or she belongs. So like this, you are going to load some information to this table. So how to load this information to tables? We have to use this syntax here. Okay, this syntax must be used. Load data, and we are going to load is locally, right? You are going to use local file system. Local file system is what? Within the Hive, we are going to load the data, so local file systems, and you have to in path, load data, local in path, you have to give the path. From which path you are taking the data? Because already we have a data, we have what is the file name of your file name is what? Data.csv. So in this file, you may have a number of records about the athlete, right? In this file you have records about the athlete. The records may be 50,000, records may be you say 60,000, it may be 1 lakh. Okay, it depends on the file size. So we have many records. So this file we are going to load into the table which you are already created based on the given schema, right? So we are going to write this syntax, load data. You are going to load a data. Then you have to specify this. This is going to call as your location. In which location your data is present. You have to give the location. You have to provide the location. In which location the data is present. You have to give the location name. So you are giving the location home, Kiran, download olympic.data. So this is the file name. What is the file name is? What is the file name is given? Olympics_data.csv. Okay. this comma separated values, this is the file formats. So this is the file name is given, and this file we are going to load where? You are going to load which table? Olympic table, which already we created. Here what happens? We are creating the table name called as Olympic. So Olympic is created this table, and this data which is already available in this location, we are just loading this data to this table using this command called as load data local in path, the location where data is located, and then you are just putting this data into this Olympic table. Okay, now here is that what is the file format given here? What the file format is given is what? Given as the text file. This is a text file is what? Is a file format. If you are not going to specify this file formats, by default Hive will take as a text file only. Now you just see the after that I am just firing the queries. This is very wonder of this. Now I am the data analyst. Okay, I don't know Java program. Fine. What I did first? I create a table. What I did next? I load data into the table. And what third things I am doing? I am just writing the query. Here, if you write this query, then your all Hive, how the inside the Hive, how the execution take place, you have to follow all these steps, 10 steps, right? No, so we are just giving these queries. If you giving this query is only going to convert it into MapReduce program. Okay, only this query is going to convert into MapReduce program. It means we are going to interact to Hadoop through this Hive and getting results from the Hadoop through this query. So if I am going to write select athlete from Olympic, it means I am giving what field? I want to know the name of the athlete from which table? Olympic table, which already we created. In Olympic table we have a data, because in Olympic table we have loaded some data. So this data is available here in the Olympic table. So if you give this query, you are going to get this result. Now who will going to give this result? The Hadoop, right? The Hadoop is going to give you results to the client, right? To the users. So this will fire by the data analyst. Then go to the Hadoop cluster. Hadoop cluster MapReduce programs will be executed. It will fetch the result from your SDFS, and it will give it to the users, right? In this way it's going to be work, right? So this is called as just simple example of the text file. So here how the data will be stored in the forms of text file only. Now the sequential file formats. See, here we have to specify the sequential file format. Is very important. If you want to store your data in the terms of sequential file, you must specify the file format, which is very much mandatory, which is very much compulsory. We have to specify the sequential file formats. So what are you doing here? Same thing I am doing. I am creating table. What table I am creating? Create table Olympic sequence file. I am creating the table. I am giving the field name with the given data types. So I am just creating the structure of the table. The structure of the table is created, and I am using the same syntax, row delimited, fields terminated by tab, what stored as a sequence file. So here I am going to specify that your data must be stored where? In the forms of sequential file, means what? In the forms of key value pair. Okay, your record must be stored in the terms of key value pairs. You are going to store the record, right? So here you are going to describe Olympic sequential file. So these are the fields are there, and for the given field we have the given data types. These are data types for this field, these are data types for this field, these are data type for this field, this is data for type for this field, and this data type of this field, and so on and so on. Okay, so this is what. So what I did, I am creating the one table. Table is created. Once table is created, what I am doing here is that I am going to load data to this table. Which table? Just now I created some table, right? What table I created? I created table called as Olympic sequential file. This table is created. Now already I have a data in Olympic table. Just remember, in Olympic table what we did? We create one table which name is Olympic table, and in Olympic table what you did? We had loaded the data. We loaded data which table? Into the Olympic table. So in Olympic table already some data is available. Okay, so what I am doing is that I am just selecting the data from the Olympic table, and what I am doing, I am just loading to which table? Olympic sequential file. It means we are transferring all this data to where? To this table, which is called as Olympic sequential file. So this Olympic sequential file will contain the data of what? Data of all the Olympic data is available where? It is available in the Olympic sequential file. So first what we did, we create one table called as Olympic table. Then what we did next, we had loaded the data into Olympic table, that is data name, okay, that is the forms of CSV, comma separated values format, and then you have data into Olympic table. The next what you did, we had what table you created? You created one more table called as Olympic sequential file table, and this table what we are doing again, we are loading data from Olympic to the sequential file, and for this we have to remember this this syntax, insert overwrite. It means the overwrite table, it means you are replacing the information, or you are just taking the information from the Olympic and you're keeping into the existing table. Which is existing table here? Existing table is what? Olympic sequential file. Okay. So here this is also one kind of command used to load data into the newly created table. So if you create a table and if you want to load some data from the other table, what you did, we can use this command. Select a star from Olympic means what? All data will be selected and just loading into the Olympic sequential file. Now here we have to mention the file format is what? Sequential file format. It's very important for you, because if you mention only, then this record on this file what is stored in the forms of key value pair. So same thing happen here. If you want to fire a queries, select athlete from Olympic sequential file, you will get the results from the Hadoop clusters, and this file will be what? It will be stored in the forms of key value pairs, not in the forms of text file. It forms in forms of key value pairs only. This will be stored in the forms of key value pair only. Keep it in mind. Sequential files can support the MapReduce, can support the Hadoop file system, right? It can support the Hadoop file systems. That's why all the MapReduce outputs will be stored only in the sequential file formats. Next topic, we're going to discuss about Hive query language. So far we came to know about different types of Hive file formats, right? We have text file formats, we have sequential file formats, okay? We have ORCP file formats. Different types of file formats are available for the Hive, okay? Coming to the Hive query languages, this Hive use some language. Always it use some language, right? No. This language is very similar to SQL, nothing more. It is very easy and it's very similar to what? SQL. So the language which is used by the Hive, is called as HQL. Is called as what? You can call as HQL, or what you can call, or you can call as HiveQL. What you can call as? You can call as HiveQL. Okay. So this language is going to call as what? HiveQL, which is called as Hive query language. So by using this Hive query language, we can create and manage tables. You can create the tables, you can manage the tables, we can partition the table. You can divide the tables into different partitions. We can do a lot of operations using these Hive query languages. Support various relations, arithmetic and logical operators. So this language is going to support various relation, arithmetic and logical operators also. We will see in the next classes about that. It's used to evaluate functions. So you can use different kind of functions to perform the operations and to get results. So you can use it support different types of functions also. Download the content of the table to local directory. See, we can download the content of the tables. You can place into which directory? You can place to the local directory. You can place to which directory? To the local directory system. Or you can download or result of queries to this directory. Or if you have result of the queries, if you are taking the result of the queries, that query result where you can keep it to which directory? To the SDFS directory. So this facility you can get it through the Hive query language. First thing, we can download the content. That contents you can keep it to load directory. Or if you have results, that results where you can place, we can place into the SDFS directory. For that you can use what? Hive query language. So Hive query language will provide you a very beautiful scenarios, how to analyze the data, how to query, how to get results, everything you can done through what? Through the Hive query languages, okay, which is just similar to SQL. That's why the Facebook peoples feel very happy to have this Hive as interface, because even they don't know Java programming, even they don't know how to use Java, but they can work with the Hadoop clusters, or they can work with the Hadoop ecosystems. So this interface you are going to get through what? Only through the Hive only. Now here, first thing is that how to create a database. Just like SQL, MySQL, you are creating database, right? It's very simple thing. How to create a database statement. You're going to write a create, you're going to write create, then you're going to write database, and you're going to specify the name of the database. What is the name of the database? Suppose if I'm going to write create, if I'm writing create, okay, I'm writing create, and I'm going to write database, I'm going to write a database, and my database name is what? My database name is final year CAC. Final year CAC is what? Is my database name, and I'm going to hit it. If I'm going to hit this command, what happens? My database is created, my schema is created. Or you can also use other things, create schema user DB. Okay, so this is the name of the database. What do you have to write? You write create. Instead of database, what you can use the schema, and you can create the database. So this is a simple example is given here. Suppose you are creating database, you have to write the same syntax, create database. And what is the create database? What is database name? Database name is what? General deb. The general deb is what? It is the name of the database. Okay, so your database has been created. Now how to show database? Suppose we have created many database, not one database. Okay, suppose I create one database. My database name is what? My database name is, suppose 4th year CAC is one of my database name. Journal DB is another database name, right? Likewise, I have created many database. So if you give this command called as show database, what happens? It will show all of the database which is created. Whatever database we have created, all the database name will be displayed if you give this command. What command if you give? If you give this command show databases, we are going to get all the database name. And also if you drop database, suppose if you want to drop database, if you want to delete the database, you can use drop database and name of the, you have to give the database name. And if you want to know much information about the database, we have to give describe database and name of the database. So it will give you all information about what? Informations about your database. That call is what database name is? General DB is name of the database. Now the most important thing is here is that by using HQL, by using Hive query languages, how we can create a table. How we can create a table. Okay, that's important things. So here, if you want to create a table, the first thing is that we have to create a database. First, what we have to do? We have to create a database. Suppose I am creating database. Okay, create. Okay, create database, and what is my database name? Suppose journal, as I am using general deb is my database name. So what steps I did? First step is what? To create a database. My database is created. Next, what I am doing is that I am going to use this database. It means in this database only I am going to create a table. In this database only I am going to do all kind of operation. Okay, so therefore if I want to use this database, I have to use another command which is called as use. Okay, journal DB. It means currently you are in which database? Currently you are in journal DB database. It means currently you are using this database only. Now here these tables, Hive describe with two types of table structures. In Hive you can find two types of tables. One type is called as internal table, internal type, which is called as internal table, and second is going to call as what table? Call as external table. So these two tables the Hive is going to maintain. Two tables you can find in the Hive. This internal table is managed by Hive only. Okay, who can manage this internal table? It can be managed by Hive. You can manage by Hive. Okay, internal table. And if you have a data in SDFS, for the processing, Suppose if you have data in a SDFS for processing, that time you can use what? You can use external table. This external table is basically not within the Hive, but it can be, you can use it for the SDFS. If data in SDFS and if you want to process the data, you can use what? External tables. Now it means if the processing data available in local file system, then you need to use internal table. What is local file system? Suppose I have Linux system. I have Linux operating system. I am using Linux system. In Linux system, I am keeping some data in desktop. Suppose I am keeping some data into where? I am keeping some data into the desktop. Okay, so it means what? I am using what system? I am using local file systems. It means from desktop I can have a data, and this data what I can do? I can load into my table. So this is called what system? It is called as local file system. So if your data is available in local file system, that time you can use what table? You can use the internal table. Okay, so here by default any table if you created is a managed table. See, internal table is also called as what table? This internal table is also called as managed table. Internal table is also called as what table? Managed table. Why? Because it is being managed by whom? Managed by the Hive. The Hive is manage this table. That's why it is going to call as managed table. So if you create a table in the Hive, by default it is called as what table? It is going to call as managed table, or it is going to call as what table? It is going to call as internal table by default. Okay, so you see here, suppose we have created many tables. Suppose how many tables I created? I created 2 tables. Say the table name is transaction record and customer. These are 2 tables I am having. First table is this one, second table is this one. Okay, so I created table, and if I want to give this command show tables, I can get whatever tables I had created. Okay, so here how many tables I had created? 2 tables I had created. One is called as transaction record and second is going to call as what? The customers. Now here if I am going to write this command which is called as describe formatted transaction record, we can find that what kind of table it has, whether it is a managed table or whether it is an external table. So if you want to find the format of your table, if just to write this command describe formatted transaction record, it says that it's going to say that it is a managed table. So what table it is? It is a managed table. It is not external table. Okay, so by default in Hive we can get only the managed table or the internal table. Okay, so managed table means table is managed by Hive, and location of this table you are going to see here. Location of the table, where this table will be stored. Okay, where this you are going to find this table here. This table is stored in this user Hive warehouse. Okay, beginner. So I will going to see about that, how it is happening, these things I will explain you. User, see, whenever the Hive will install, the Hive will automatically create call as warehouse. Going to call as what? The warehouse. Okay, so when you are going to install a Hive, suppose I install a Hive, then automatically the Hive will create one directory or a folder which is called as warehouse. What house? It is going to call as warehouse. Okay, so this is a file or directory which can be created during the Hive installment. When you install the Hive, we get this directory by default which is called as warehouse. What is warehouse again? This warehouse is what? It is collection of all database. Whatever database we created, we can find them in this warehouse. Suppose if I created 5 database, we can have details of 5 database in warehouse. Suppose I created 6 database, we can have detail of 6 database in this warehouse. You can say that warehouse is what? It is collection of all the databases, that is called as what? Warehouse here. It means you see here this warehouse, this beginner.db is what? It is a name of the database. It is name of the database. It means I had created one database whose name is beginner.db. So this beginner.db is database which I had created, and automatically what happens, this database is going to store where? It will be stored into this warehouse. In this warehouse we can find this database. What is database name? Beginner. Okay, beginner.db is the name of database which is already placed in this warehouse. Okay, again my question is that inside this database what are you going to get? Again, what is database? Database nothing but it is collection of tables. We can find many number of tables inside this database. So in this database I have what table? My table name is transaction record. Transaction record is what? It is the name of the table. So this is going to call as what? The name of the table we have. We are going to call as the name of the table we have, right? And this is going to call as what? Database name we have, name of the database. And this is what? Automatically Hive created what directory? What directory it has created? Warehouse directory is created. And what is the location of this warehouse? It is inside user/Hive/warehouse. Okay, so this is the default location. The default location of what? Location of the warehouse. The user Hive warehouse. Inside warehouse what you can find? We can find database. Inside database what you can find? You can find the table. Inside table what you can find? We can find a file. You can find a data inside what? Inside these tables. So this is what the manage table. The manage table is managed by the Hive. By default we are going to get internal table which is called as manage tables. So these are two tables, manage tables and external tables. So you are talking about which tables here? You are talking about the manage tables only you are talking. Now you see how to create the internal table is very simple format which already we discussed in the last classes. This is a command you are going to give. This is what? This is going to call as create table. You are going to create a table and this will specify the table name. This is the name of the table. What is the name of the table is given? Guru Hive underscore internal table, and this is called as what? A schema which is defined. It means we have two field. One field is called as ID. What data types are given is integer data types we specified. Second field is what? It is a name and a string. And row format delimited. You have to write this one compulsory because it is going to see your record in the forms of row. And how fields are terminated? Fields are terminated by tab. It means if I am going to write Syed, then I am going to give some tab. And what is the next is name. Okay. Suppose first this is called as what? You are going to call as name in the forms of a string. And what is ID? Suppose my ID is 101. So you have to give some space in between the field. Okay. So if you are going to write like this, in this way what happens? The structure will be going to develop in this inside this table name called as Guru Hive internal tables. Okay. Now this is the way you have to create the table. Now how to load this data into table? Same thing. You have to use the same syntax. You have to use load data in path, right? In path, and you have to specify the location where data is available. Okay. So for this we have data name is called as what? Data.txt. It is a text data. In this file we have many records, and each records contain how many fields? Two fields. One is called as ID and second is going to call as name. So we are going to load this data where we are going to load data where into this table which you created. Okay. So whatever table we have created, we are going to just load this data into this table. So you have to give this command load data in path, and you have to give the location. This is going to call as location. You are giving the location into which table? Table name is what? Guru Hive underscore internal table. If you want to display the content of the table, simple queries you have to write. Select a star from the name of the table. If you give, you can find all the content of the table. You can get it from here. And next is what? Drop the internal table means what? If you write this command, what happens? The table is going to be dropped. You can drop the table. So these are simple commands, just like SQL. We can work out in Hive also. So this is a simple snapshot I have taken for you. You are just writing the same command. You are writing create table, and this is the name of the table we have specified. This is the schema we have defined. We have ID, then we have name, string, and you are using this command. If you hit it, your table will be created. So your table is created, then you are going to load data into this table. So you have to write load data in path, and you have to give the location of this table, location of your data where data is available. So what happens? Automatically this data, what data will be loaded into this table itself. So you are loading this data from here to there, from here to table. Now if you want to fire this query, what happens is here the may produce programs are going to run. Here only you are going to get what programs? May produce programs are going to run. It means this SQL query, this SQL query is going to be converted into may produce programs or may produce jobs to get output from the tables, because you are storing tables where you are going to store data where into the SDFS only. So what happens? Finally you are going to get result from the given Hadoop clusters. Okay. So you are going to give these queries and you are going to getting the results. So this is what table? It is called as the internal table. So first you are creating the table. First you are going to create a table, right? Second, what you are doing? You are going to load the table. You are loading the table, and if you want to display the content, we have to use these queries to display the content, and if you want to drop the tables, you have to use this query to drop the tables. So this is called what table? It is going to call as the internal table. Next one you have call as what? The external table. See, when you have to use internal table, if you have data in local file system, then that time you have to use internal table. But if data will be available in SDFS, and table is going to create on SDFS data. So if data is available on SDFS, and if you want to create tables in SDFS itself, then you have to use what? You have to use what tables? We have to use the external tables here. When to choose external tables? If processing data available in SDFS. If the processing of data is available in SDFS, that time only we need to select external table. Useful when the files are being used outside of the Hive. So you are not going to use the file within the Hive, but if you are using the file outside of the Hive, that time you have to use what kind of table? We have to use the external table. Now this is the way you have to create the table. See, the syntax of internal table, external tables looks like a similar, but you have only one basic difference. I will tell you. First you are going to create a external table. It means you are going to create a external table. You are going to create a table, external table. You have to give the name of the, this is the called name of the table. Then we have a schema. You're going to define the schema. We have a field ID and we have a name. Row format delimited like an internal table. Field terminated by tab. Here you have to specify the location. This is what major difference. In internal table, we are not going to specify any locations. But in the case of external table, you must specify the location of this table, where this table has to be created. You have to specify the location. So this location is given. Locations user Cloudera Guru Hive external. This is the location of this table. So you have to specify the location. So this is a basic difference. For internal table, no need to specify location. But for the external table, you must specify the location. You must mention the location in the case of external table. And here, how to load data into the external table? The same thing. We have to load data in path user Cloudera data.txt into table name. What is table name is given is the Guru Hive external table name given. You are going to load the data. The data will be loaded. And how to display the content of the table? Same thing. Select star from Guru Hive underscore external. You are going to get the content of the table. And how to drop the internal table? You have to use drop table and the name of the tables. The content will be going to be a drop out. Okay. And this is a simple snapshot I have taken here. Right, you are going to create external tables, and Guru Hive external table. You are going to give the ID, integer name, schema defined, row format delimited, fields terminated by. Here you have given what? Field terminated by comma. You are not used tab. It means if I am going to write ID is 101. Okay, a name is suppose Syed. How you are going to separate this field? You are going to separate this field by using comma. This is meaning. It means this field is separated by using comma. Suppose if I am writing 103 Murli Krishna, if I am writing Murli Krishna, what I am doing here is I am just taking the ID number, and this two field what? This two field is separated by the comma. Okay, this is what here is. So you can write comma if you want. If you want semicolon is what? The field is separated by the semicolons. So the fields terminated by comma. So you have to specify the location must, because for creating external table, the location should be mentioned location also. And then you are going to load data into the external tables. Then you are going to fire the queries. You are going to fire the queries. Then what happens? May produce programs are going to execute and going to get the output. This is what tables? It is going to call as the external tables. Now we are going to see the difference between managed table and external table. This is very important thing. See, sometime in interview, this kind of questions they may ask. What is the difference between internal table and external table? One difference of internal table is what? See, if you create internal table, right? If you create internal table and if you drop the internal table, what happens? The table and data both will be deleted. In internal table, or you can say managed table, if you drop the table, both table and data will be deleted. What in the case of internal table, but in the case of external table, what happens means, if you create external table and if you drop the external table, what happens? The table will be dropped, but data will remain as it is. Data remain as it is. No, data will not be going to be deleted. You cannot delete the data in the case of external table. So this external table where you can use, suppose I am doing some project and I want my data will be safe. Nobody should delete my data. Okay, I am doing some big projects and I want my data should be very much safe. Nobody should delete my data. In this case, what I'll do, I'll create what table? I create external table, because I make my data should be safe. So if by mistake if somebody delete my table also, I can get my data into external table. But in the case of internal table, what happens? If somebody drop your internal table, you lose both. You lose table also and you lose data also. This is one basic difference. Second basic difference is what? In internal table you should not mention any location. No need of using location in the case of the internal table. But in the case of external table, you must specify the location. Location is required. It is must what in the case of external table. So I am just stopping of my class for today's session. I hope you understand the Hive architectures, how the Hive inside Hive, how the execution is taking place. You understand about the different data types of Hive. We understand about the Hive file formats. We have different types of Hive formats are there, and you understand how to create table. We have two types of tables: managed tables and called as external tables. We discuss. So next class is going to see how you're going to analyze the data using the Hive. Okay. So thank you very much for today's sessions.